Are you secretly throwing away your graphics performance? Seriously, your current computer setup might be hiding some massive performance traps, literally bottlenecking your workflow and ruining your games without you even knowing it. Well, today we're going to fix that.
Welcome to this explainer. Today, we are decoding the entire graphics processing landscape. We're going to start right at the foundation, with the basic hardware inside thin, everyday laptops, and we'll scale all the way up to the melting hot, liquid-cooled data centers that are powering modern AI. By the end of this, you'll know exactly how this hardware works, and, more importantly, how to stop wasting your money.
Okay, let's dive right into this. Here is our roadmap. First, we'll hit the everyday GPU essentials, then dedicated desktop gaming powerhouses, followed by laptops and portable graphics, professional and server hardware, and finally, AI and cloud computing. Let's scale up.
Section 1. The everyday GPU essentials, built right into your CPU. Let's start at the absolute foundation, with the integrated GPU. This is a graphics processor built quite literally in the exact same chip as your main CPU. These are incredibly common in laptops because, well, they're cheap to make, and they absolutely sip electricity. That efficiency is exactly why your laptop battery can survive a full day of web browsing and office work without needing to be tethered to a charger.
But here's the hidden catch. While integrated graphics are fantastic for everyday basic tasks, they lack their own dedicated memory. So to run heavy software, they physically have to steal a portion of your regular system RAM. If you fire up a modern AAA game, you instantly create a massive data traffic jam. Everything stutters, and your frame rate absolutely tanks.
So, what is the insider secret to fix this? Well, if your computer only has one stick of RAM, all that data is forced down a single-lane dirt road. But by simply adding a second stick of RAM to enable dual-channel memory, you literally build a multi-lane data highway. This one ridiculously simple upgrade can boost your gaming performance by up to 40%.
And that brings us to a really crucial buying secret, decoding the processor name itself. For AMD, the G suffix, like on the Ryzen 5 5600G, means an integrated GPU is included. For Intel, you gotta watch out for the letter F. If an Intel chip ends in F, it means it has absolutely no integrated GPU.
Section 2. Dedicated desktop gaming powerhouses. Maximum performance, maximum heat. This is where we step up to the big leagues, folks. A dedicated GPU is a massive separate expansion card that you plug directly into your computer's motherboard. They are built specifically to handle incredibly demanding, high-resolution graphics workloads.
The difference here is night and day. Unlike an integrated chip, a dedicated GPU comes with its own completely separate memory, called VRAM. It never has to borrow from your main system, meaning it can load massive high-resolution textures instantly. The trade-off? Extreme power consumption and insane heat, which is exactly why these massive cards are strapped with giant cooling fans just to stop them from crashing.
But wait, you absolutely have to balance your parts, otherwise you hit the dreaded CPU bottleneck. Imagine buying a brand new, incredibly expensive RTX 4090, but pairing it with a really old, weak Core i3 processor. That is literally like putting bicycle tires on a Ferrari. The weak CPU physically cannot feed data fast enough, so your massive new GPU just sits there idle, waiting for instructions.
Just like we saw with CPUs earlier, dedicated graphics cards have their own secret language. NVIDIA's TI or Super tags indicate a slightly upgraded version of the base card. For AMD, XT or XTX flag their absolute maximum performance tiers. Know these, and you'll know exactly what you're paying for.
Section 3. Laptops and portable graphics, or as I like to call it, the illusion of mobile power. When you buy a thin laptop that claims to have an RTX 4080 inside, you need to know that it is vastly different from the giant desktop version. The name might be the same, but the power is definitely an illusion.
That illusion all comes down to TGP, or total graphics power. Because modern laptops are so incredibly thin, they physically cannot handle desktop-level heat. To prevent the laptop from literally melting on your desk, manufacturers enforce TGP. They heavily limit the power wattage and lower the clock speeds. A mobile GPU is simply always going to be weaker.
But here is where we uncover what might just be the biggest scam in gaming laptops. In most laptops, even when your powerful dedicated GPU finishes rendering a beautiful game frame, it is forced to send that finished frame through the weak integrated GPU first before it can actually reach your screen.
I mean, why? It creates a terrible bottleneck. You end up losing up to 15% of your frame rate simply because of how the laptop is wired internally.
So what's the hardware solution to this? It's called the Mux switch. This is a physical chip inside the laptop that lets your dedicated GPU completely bypass the weak integrated graphics, connecting straight to your display. If you're shopping for a gaming laptop, you have to ensure it has a Mux switch or Advanced Optimus. If it doesn't, you are just throwing away performance.
Now what about external GPUs or eGPUs? Putting a desktop card in a metal box and plugging it into a thin laptop sounds like the perfect hybrid setup, right? But there's a pretty huge catch. A Thunderbolt cable can only send a heavily limited amount of data compared to a true motherboard connection. You lose a huge chunk of performance to that cable bottleneck. It works, sure, but it's an incredibly expensive compromise.
Section 4, Professional and Server Hardware, for engineers, architects, and data centers. Okay, we are officially leaving consumer hardware behind. Workstation GPUs look exactly like standard gaming cards, but they cost 3 to 4 times as much. And shockingly, they don't actually give you higher frame rates in video games. They perform about the same as regular cards.
So why the massive price tag? It's all about ECC, or Error-Correcting Code Memory. Imagine an architect rendering a 3D design for 3 literal days. A microscopic data error in standard RAM could corrupt that entire multi-day project in an instant. ECC memory automatically finds and fixes those tiny mistakes on the fly. Professionals happily pay the premium just so their rendering never crashes. Then you have enterprise server GPUs, like the NVIDIA A100. Unlike standard cards with fans and display ports, these look like featureless, flat metal bricks. They have no display ports and no fans at all. They aren't meant to connect to a screen. They sit in enterprise server racks where massive fans blast them with cold air, allowing them to run at absolute full power 24 hours a day for cloud gaming and simulating complex scientific data. Section 5. AI and Cloud Computing. The liquid-cooled behemoths. This is the absolute peak of our escalation arc, the AI GPU. These are the most advanced processors on Earth right now. Instead of rendering 3D graphics, they use highly specialized tensor cores purely to crunch the massive math required to train huge AI language models. To feed data into those AI cores fast enough, they literally have to abandon standard graphics memory. Instead, they use HBM, or high bandwidth memory. This memory is physically stacked right next to the chip itself, allowing data to move at terrifying speeds, terabytes per second. But they run so incredibly hot at maximum capacity that regular air cooling completely fails. Server racks packed with these chips, like the NVIDIA H100, require massive liquid cooling systems just to keep from melting. They're then connected together via a high-speed bridge called NVLink, essentially turning thousands of these chips into one single giant supercomputer.
So how does all this crazy enterprise hardware actually help you? 2 words: cloud GPUs. Instead of buying a massively expensive workstation yourself, you can just rent one. You use your thin laptop to connect to a cloud provider, the heavy lifting happens remotely on their massive server GPUs, and only the finished results are beamed back over your fast internet connection straight to your screen. It basically gives everyday users supercomputer power on a total budget. Which brings us right back to your desk. Knowing what you know now about dual-channel traffic jams, CPU bottlenecks, and missing mux switches, I have to ask, is the computer you are using right now secretly bottlenecking your potential? And more importantly, now that you have all this insider knowledge, what are you going to do to fix it?